Let's solve some exam questions regarding the mean and the standard deviation. Let's look at this one. This is from spring 2015, question paper 61, question 5. The table shows the mean and standard deviation for the weights of some turkeys and geese. So here you have here the number of the birds, you have the mean for each one of them, and you have the standard deviation for each one of them. First question is find the mean weight of the 27 birds. So you want the mean of the turkeys and the geese all together. And in order for you to know that, you need to know the sum of the individual weight of each one of the birds. But the only thing that you are given for each one of them is the mean. So how do you solve this? This is always the same. This is what you need to get the mean, the total mean. That's what this means, the T. So you need to know the total weight of the turkeys and the total weight of the geese. And you can get that with the information on the table because you are given the mean and the number of birds. Just apply the formula for the mean for each one of them. This is what you need, these bits over here. And you do have this on the table, and you also have this. So what is this? This is just the mean of all turkeys, which is 7.1, times the number of turkeys, which is 9. And here you have the total weight of the turkeys. Do the same for the geese, and here you have it. So you just now add them over here on the formula for the total. Divide by the total number of birds, which now are going to be 8 plus 18, so 27. And here you have the total weight, or the mean weight of the birds, regardless of being turkeys or geese. Pay attention to one detail. The final solution should be given to 3 significant figures, but every time you get a mean, chances are that you are going to need this to calculate the standard deviation because it's part of the formula. So you should write down on a side note the value that you got on a calculator with one more significant figure so that you plug in on the formula, and the final solution for what you are being asked, the standard deviation in this case, is also given in 3 significant figures. Not that it is the case over here. No, it's going to be, yes, 3 significant figures. All right, so let's look at the question. The weights of individual turkeys are denoted by xt, kilograms, and the weights of individual geese by xg. By first finding the sum of xt squared and the sum of xg squared, find the standard deviation of the weights of all 27 birds. It actually tells you what to do. You need to get first what? You need to get first what you have. You want this. Where is this found? This is found on the formula for the standard deviation. All right. By now, you should know by heart the formula for the standard deviation, and the sum of individual items squared is the first part of the formula for the standard deviation. This is divided for turkeys and geese. So if we want to get this, we know all the other things. We have to do the proper algebraic manipulation to this. So I isolate this part that I want, right? So I square the other side, I bring that to the other side, and then I multiply by nt. That's what I did over here. And then it's time to substitute. What is this? Is 1.45. What is this? Is 7.1. And n is 9. Put it in a calculator, again with one extra significant figure, 4. This is the value. Do exactly the same thing for the geese. Substitute, and you'll get that value. Now that I have these two values squared, I can apply the formula for the standard deviation for the birds as a whole, right? So what is going to be this? It's going to be the sum squared of all the weights of the turkeys and the geese, which we just found, divided by the total number of birds, which is 27, minus the mean of the weight of all birds that we calculated in the previous question, which is this, and you plug in the value with 4 significant figures, calculator, and write down the result to three significant figures again. Next question, this is from spring 2010, question paper 61, and the question is question 4. The number of rides taken by two students, Faye and Graham, at a fairground are shown in the following table over here. So here you have how many times they went in each one of these. So Faye went 4 times in a roller coaster, 2 times in a water slide, and he didn't go at all to the revolving drum. And Graham went 1 time in the roller coaster, 2 times in water slide, and went 6 times to the revolving drum. The mean cost of Faye's rides is $2.50, and the standard deviation of the costs of Faye's rides is $0. Explain how you can tell that the roller coaster and the water slide each cost $2.50 per ride. This is basically and very clearly assessing your understanding of what standard deviation is. If the standard deviation is 0, this means what? This means that you have no spread. You only have no spread if the values are always the same. In this case, what values are we talking about? Is the cost of tickets. And you have 2 different types of tickets. It didn't go over there. So if the standard deviation is 0, means that the tickets must cost the same. How could you provide this answer for an exam? I have 2 different ways. I use math and I use English. So I use both languages. I'm going to start with the English. So I wrote, if the standard deviation is 0, this means that there is no variance, and this only happens if there is no difference between the individual price of any ticket and the mean of them all, which, in other words, means that they all cost the same, $2.50. You got this value, by the way, because it actually tells you over here already. Mathematically speaking, how would you get to the same conclusion? Well, they're talking about the standard deviation. What is the standard deviation? Is the sum of all values, in this case is the prices, squared by the total number of rides, minus the average, the mean price of the ticket square. And you have that. The mean cost of Faye's rides is $2.50. So we have this. And we need to get these two, all right? So this is for the roller coaster, this is for the water slide, all right? So what is the sum of the cost squared? Is the cost of each individual ticket times the number of times Faye went there. So for the roller coaster, it was 4 times the price of the individual ticket for the roller coaster. You went twice on the water slide, so that's 2 times the price for the ticket for the water slide. A total of 6 rides. Plug this in a calculator, and you know that this is 0 according to the question. So let's do some algebraic manipulation. Get rid of the square root by squaring both sides. Then send this to the other side and multiply by 6. That's where we are right now. And now look at what you have. You have 4 times the price of the roller coaster square plus 2 times the cost of the water slide square equals 6 times 2.50 square. In order for this to be true, you have here, look, pay attention to the coefficients. You have here 6, 4, and 2. In order for this to be true, this will only happen if this value over here and this value over here are the same, which I just call x, right? Let's see what the value should be. If I just call x over here, so this will become just 6x squared equals 6 times 2.50 squared. I just get the 6's. I square root both sides, and I prove that the cost needs to be 2.50, right? So using the language of math, I came to the conclusion that first, the price of the ticket must be the same, and then I actually got the value, $2.50. And I think that this would be it. No, you still have another question. The mean cost of Graham's rides is $3.76. Find the standard deviation of the costs of Graham's rights. Now we're focusing on Graham. We already know that the price over here is 2.50, right? We don't know that price yet. But we know that the mean cost of all rides is 3.76. So we have to use the formula for the mean to get what we need, which is the standard deviation. I know you need the standard deviation, but you need to get the value of the price of that ticket first. So in order for you to get the standard deviation, you need again the price of each ride squared times the number of times that person went on that ride. And we have that information for this. This is 2.50 for each one of the roller coaster and the water slide. We already know that. Graham went once on the roller coaster and 3 times on the water slide. So that's what I have over here, 1 and 3. But we don't know this. We just know that he went 6 times on the last one, which is the revolving drum. But we don't know the price for the revolving drum. We know everything else. We know that he went 10 times. It was a total number of rides that he took. We know the mean. The question tells you it's 3.76. We need to know the standard deviation. That's what you are being asked. So we're going to make here a pause in order for us to get that information first. And we do that by getting the mean of the price that he paid. So that, where is it? So that we get the information that we want, which is this over here. All right. I'm going to do some algebraic manipulation before substitution using just this. So this isolated is going to be this times that minus these two, right? So what are we going to do? We are going to substitute n is 10. The average of the price paid by this fellow is 3.76. We already know the value of this ticket is 2.5, and you only ride it once there. It's also 2.5 for that one, but you went 3 times on that one. So calculator, and you get a value of 27.6. Divide this by 6, and you have a price for this ride of $4.6. Now that we know this, we go back to this equation where we left it, plug in the value there, put everything in a calculator, and you get the standard deviation of $1.03. I want just to make a small note on the importance of presenting the information in the right order. Don't forget, we are talking about math. Math is a language, and you are explaining things to the examiner or your teacher, if this is a test, using the language of math. See what I did here? I started by explaining how I intend to get the standard deviation. I got into a problem, so I stopped there, and that's what this one means. This means that I'm going to try to get something else, which is that value over here. I got it, and then I pick up that formula where I left it. I plug in the new value, and I get the final result. All right? Instead, most people, from my experience, what will they do? They get on the paper that they have available, they do the calculations with no particular order. Then it's up to me as a teacher to try to figure out where the information is. Don't forget that an examiner has limited time to correct exams. He's paid by exam. So if he doesn't understand at first glance what you are doing, he's just going to go to the next student. And even though you may have the correct information somewhere in all the little things that you wrote there, it may happen that you may be attributed to 0. Okay, so get used since the beginning to write down mathematical information with the same structure that you write sentences in English or whatever language. Okay.